Okay, so I'm live streaming, but I can't seem, nothing looks normal. I gotta get it out of the wall. Hopefully that will help. So you can go watch on your computer or on your phone. I'm sorry, I don't know what to tell you. You can hear me. And there's a delay, so you're gonna get confused. Yeah, mute. And I'll just go slow enough. Okay, so, but I don't know what's wrong with my image either. It screwed up my image. All I want is the iPad. Okay. Is that working? I can't see anything. Okay, I got something. Okay, I got something. What is this? All right. Now, I don't know why the image is so messed up. It was from putting it into the wall. Does anybody work with OBS?
Yes.
You want to come and see? I don't know why. So my video device is the iPad. It's connected, but it doesn't, it's distorted, sorry.
It's okay. Pero qué pasó? Es que I don't understand Mac.
Yeah.
I use Windows.
Yeah, but it should be similar. No. That this image. No,
but it
shrink it, right?
Yeah, I don't know. You should shrink it.
Or I have to make this one bigger.
No, hold on. I'm sorry.
No, go ahead.
How you can like put this?
I don't know what happened. It's distorted. It's not like that usually.
No,
you know what? Maybe go to the display. Change the display.
No, this is too big. This part here.
Yeah, I know. I know. It's very different. It looks different for me too. Let me see the display setting. It got distorted. No, displays. Because I had it hooked up.
Maybe you should quit this.
No. Which one? No, I already did. This is just a plug. I already did, okay. But it's distorted. Maybe I should stop it and open it again.
No, do another one. There you go. Another video capture. So maybe there. There you go. Now you have
close this one.
Yeah, I'll leave it there.
Okay, you guys see something? It's still distorted. But okay. I'm not going to do that again. No, you guys, we're just going to, I'll just, I don't know.
It looks too big. It looks like this.
How about it delay? Because of the delay. Ya llegó completo, ¿verdad? Yeah.
Okay, so
still, this is.
I don't know. It's distorted. I know. I don't know why. I have to reboot. I think. It's very distorted. So plugging my machine into the wall has distorted my vision here. And what is this behind? I don't know. Oh, I have to just close that one. All right. So you guys can see what I have displayed. Everybody can see on their phone or somewhere? Okay.
Yeah, I see period, S&P 500X.
So the risk and return formulas is the title, right? So how many of you completed the statistics review? You need to have completed the statistics review for this class. No one? The statistics review ends up in this document. And what I'm thinking, if you guys didn't complete the statistics review already, honestly, you're really slowing me down. I wanted to talk about this and introduce where this data comes from. Okay, these are return data, and they're two variables. One is a measure of the performance of the stock market, which reflects the state of the economy. And the other one, the Y, BCE, are the returns to a firm. And I wanted to discuss today how those things are calculated. But so I'm going to leave you to do the statistics review. I'm going to talk about this data. And then next week, we're supposed to have the test next week, but I don't feel confident, if you guys didn't do the review yet, that you're also going to learn this material.
Just to make sure, Professor, the statistics review is for the next test, not this one, right?
It's for this one. It's for this material.
Oh, but it's, I didn't move it in the wrong chapter then, because in 5 and 6 is not this. I didn't see the statistics.
But I never said that the test was only unit 3 and 4. It should be 5. It should be 5 too, because we only have a second test and then a final exam. We have to do some of 5. The final exam is supposed to be comprehensive.
So there's
So this material is necessary to do the rest, like all of unit 5, together with what you already learned, because we're going to combine everything together. So I gave you those materials so you can review statistics. And if you didn't learn statistics before, you're going to learn the important components of statistics now. And then we're going to apply it. So I don't know what to tell you. If you guys are here today because you think it's a review for the test, right? But I gave you so much material to review for the test, I don't know what else I can do. If I ask you, what do you want to review on the test? What would you like to review? Because I'm just going to solve problems I already solved. Is that what you want me to do for the test? I just feel like this is so difficult because I give you everything. I give you the questions, I give you the answers, and I even solve them on video. If I ask you which problem would you like me to do, can you tell me which one you would like me to do of unit 3 or unit 4? Do you have questions? Because if I start this, again, you have to go back and still review statistics. So your review of statistics should culminate in this document, and there's another document as well that looks similar, but I change all the symbols to be returns data, return symbols. Sandra has a question. Nobody else has a question?
It was more of, so when you say the final exam is comprehensive, it's like set everything in one, and then the first exam, are we retaking it before that?
We have to do a retakes. The retake I wanted to do this weekend, but I guess I have to do it next week. And some people complain. I mean, I don't think you can complain about me offering you a retake. I mean, you're lucky I'm offering you a retake. So no complaints. But I was thinking, because my Saturdays are busy, the only thing I can think of is Friday evening, this weekend or next weekend. That's all I can think for the retake.
So it would be a.
For the retake would be unit 1 and 2.
But I mean for the dates.
The dates. So that would be April. This is not good. This is dirty. This is dead. 1 second.
Okay, so the retake will be the first, then it will be the second. Is that correct?
Sorry.
Would it be 28 will be the retake, and then May 2 will change the second test? Is that what I'm?
So what is the date for the second test?
Originally it was 25th.
Right, exactly. So I mean, I could postpone it, but let's see first. Okay, so the makeup test, I what about Friday? This is terrible. That's 28? Is that what you have, the 28?
Yeah.
That would be next Friday.
Yes, 28 will be next Friday.
And just here in one of the rooms here. And then, I mean, I don't feel good about changing the date for the third test because people will not be here because I didn't warn them. So I don't feel great about that. I feel like having the test next week, but just having it on unit 3 and 4 because, but see, then you're gonna study all this week on unit 3 and 4 again, and we're gonna still be behind. So if I make the test next week on 3 and 4, you need to do the statistics review for next week.
I honestly, I did a mistake and I thought it was only
3 and 4.
yeah, and that's why I didn't do it because I didn't know.
I know. Well, trust me, when I give you dates, abide by the dates because you're gonna fall behind. We're already so behind. So, so test 2 is going to still be on Tuesday. And I'm there on video, but nobody can see it. April, I should be writing on the iPad. April 25th, unit 3 and 4. And and then due for the next week is May 3, right? The next Tuesday?
Yeah.
May 2? So somehow you guys have to study unit 5 for May 2. The final test is supposed to be 2 weeks after that. I mean, I can make it. I'm just going to say unit 5. I don't know how to specify. I have to give you a page number or something. If you make this your goal, May 2, for unit 5 completion, that means you have to self-study. You know, I give you everything. You have to pace yourself. I give you everything. I don't feel any, I don't feel like I've kept anything from you. So that's 2 more weeks to finish unit 5 in my mind. All right. Otherwise, today we were going to do the beginning of unit 5, where we're going to do unit 5, most of it. But okay. So let me put this on here because there might be people watching. So what did I say? The makeup test.
The university already scheduled the final exam?
They sent a tentative date, but I think I'll just do it on the Tuesday in the exam period. Does that work for everybody? That's usually what they do anyways. They put it in the exam period or on the same day of class. The exam?
Yeah, the final one.
The exam period starts May 19. Let me check. Anyway, let me write these dates down. Okay, so May 23 would be the final. So makeup test. So I'm saying Friday, April 28th, from 6 p.m. to 9 p.m. And then test 2 will be Tuesday, April 25th, Again, 6 p.m. to 9 p.m. And that's going to be unit 3 and 4. And then the oh, what else do I have there? So unit 5, you should be completing on your own. Tuesday, May 2nd. And then the test will be on May 23rd. All right, so you guys are watching on your computers and we're here. It's the only way I could do this properly. But look at the board, it's a mess. Like, they don't even have I shouldn't be complaining. They don't have the it's on a recording. The resources, like, seriously, can't they get the right pens or the right, what is this called? Plastic or vinyl? Anyway, okay, so any questions about that? So the final exam should be cumulative. And
Incluye la unidad 6, ¿verdad?
with unit 6. The point is this course, it builds. So the skills you learn in unit 1, you're going to learn all the way to the end, or you're going to apply all the way to the end. So I have to write that neater because that was really messy. Cumulative. 1 to 6. So let me see if I can put this up better. I'll just have to come this week and have somebody set things up for me. And usually I carry my own cleaner for the board. But hopefully I don't have to use the board. I can display my iPad. Okay, so what do you want me to do? Sandra was going to ask me a question from unit 4. Unit 3. Anybody else? No questions? Have you finished your review of unit 3 and unit 4?
Gateway.
Es en el first review, la pregunta 7, el numeral 6.
You review 1?
Sí, correcto. La pregunta 7 y el numeral 6.
I feel like I have a different review 1. Let me see.
No, very sick.
Yeah. Oh, and 3, I'm looking at 4. No. I'm gonna go, first review,
Correcto.
question 7.
Correcto. Y el numeral 6. La pregunta es, ahí se dice que es posible que los proyectos A y B tengan el mismo net present value, pero yo hice el cálculo de ambos net present value y no me dan lo mismo. Entonces no sé si de pronto fue un error al hacer el cálculo o...
The issue is that you're supposed to ignore, well, they give you the discount rate for A. But in C, you're supposed to say you don't have the discount rate. But it's not clear. No está claro. Okay? But that's what you're supposed to think, because it says here in B, ignore the information in A. It's the same in C, ignore the information in A. And then you have to think, in other words, do they cross? Esa es la pregunta. Do they cross? Can they cross? So A and D. So A, they can cross because look at how the cash flows are. One is going, A is low to high, and D is high to low. So they can cross because of timing of cash flows, I think. Does that help? I'm just projecting on the platform. You can see. Do you guys understand what I'm saying? No? Yes? So the cash flows. So there were two issues of where. So it's clear if one NPV profile is on top of another one, that the NPV is always higher, you pick that one on top. But what if they cross? So when can they cross? They can cross when one project is a higher budget project. I talked about that example. So it's just more money going in, and you're getting more money out, but in percentage, it doesn't look that great. Or timing. So in this case, the cash flows are reversed in timing. So that means that A doesn't mind, so A prefers low discount rate so that the 140 is relatively high. D prefers or doesn't care if it's a high discount rate because the 140 is the highest cash flow, it comes early. So you can see that they will cross. So the key here was understanding that you have to ignore the information from A. Sorry.
Okay, no problem.
I'll do my best to make it clear in the exam.
Okay.
Other questions about this? Have you made your way through Unit 3? Everyone, you think? Unit 3? And I also gave an old exam in Unit 3, right? And then at the end of the old exam is a Unit 4 problem. Did you want to do that one together? On the exam that I put in Unit 3, the old exam, there's also a Unit 4 problem that I repeat. But I gave you the answers? I gave you the answers for it too. Do you want me to find something I didn't give you the answers? I have, you guys can see my view. I have some things hidden. Do you have another question, Unit 3? No? So Unit 4. Okay, so here you have, I can unhide this set of problems. How about that? Or unless you have any of these in Unit 4 you want me to look at. Any questions in Unit 4? We can do a problem from beginning to end together. I can give you a new problem. I have it here gray. I can change it. There's 4 problems here. Okay. Let's do the one I have the answer up for. Okay, let's do problem 1 together. Peter Pepper, owner of PPP Plastics Incorporated, is pursuing a government contract to produce a specialty space-age plastic for NASA. Did you see this problem before? Hi, Michelle. No? Okay, so we are on, you figured out we're online, right, Michelle? Yeah. Because none of this is working for me. Okay. Okay, so go for it. You guys can work together, work alone. Give you 15 minutes and we'll look at the answer together. Well, 20 minutes, 20 minutes. This is from my other class. I opened it so you can open it on and download it on the page. It should be on the bottom here. Just reload and you'll see it. Can't see it on the. Let's see. Um, you can view it, right? Watching it here. How many of you are comfortable working in Excel? Oh, you like Excel? But will you be able to do this on a test without Excel?
This right now, since I haven't practiced with Excel, no, but I'm 100% sure I could if I practice with it.
Yeah, no, you don't, I don't think you won't need Excel for the test. You should be able to do it both ways though, Excel or no Excel. But you don't have to use Excel for the test. No, because you can't have your computer.
Exactly.
No, I just want to make sure that you're preparing for the test, that you're not using Excel, thinking you can use it on the test. But you can, if you can reproduce your answers in Excel, that's not bad. That's not bad. It's just you need to be able to do it without Excel for the test.
Because in the first one, I got some answers.
For the first one?
Yeah, I got some answers with the.
Okay, so do you guys want me to start breaking it down? Let's break it down. I'm going to work on my iPad because, so anybody who's just watching, I put up the document in the platform so you can get it from there because I'm going to change the screen here. All right, so what we want to do, let me save this. I have to put this in Dropbox. Okay. Are you watching me? Yeah, I have it in the platform. It's on YouTube right now. Okay, so we're going to do this. I leave it open, right? Compute the NPV of the government contract proposal and then interpret the NPV, indicating whether the firm should pursue the government contract. So we're going to do this as I taught you in 3 parts. So this is hard to do standing up. Okay.
You can sit down there.
Yeah, I'm gonna have to sit down. My stuff's all over there. Okay, I'll stand up. Okay, so PV of income. Which portions, I'm going to mark them with a red underline, which portions of the problem are income? So I'm going to read this through and you stop me when it should be considered part of income. The contract will last for 4 years. If they win the contract, it will have to invest 1.8 million in production equipment, but expects to be able to sell it to a competitor after the 4 years for 350,000. That's not income, right? This new machinery will be placed in an asset class that depreciates over 7 years. The government contract calls for PPP to receive pre-tax revenue. PPP also has also estimated the additional expenses per year. If it lands the contract, raw material inventories related to plastic production will have to be increased immediately and will have to remain the higher levels until the project is complete, at which time they will then return to pre-project levels. What's that? Investment, right? That's net working capital. The firm also estimates that landing the government contract will result in an increase in sales of their regular plastic products by 100,000 per year, and that this increase will last indefinitely. Sales? Income? Yeah.
Yeah.
I'll just underline the values. And then assume the firm's Corporate tax rate is 40%, its hurdle rate is 13.5%, so that's another term for required rate of return. Hurdle is like they have to jump over or achieve more than this to make it a viable investment. Is the present value,
It's 1.8, 200,000, and 300,000, right?
I think so.
Okay.
No, not the 300, the 300, oh yeah, 300 is the inventory, yeah. And then the last amount is the tax shields, and I'll put it in green. So you see here, we have an amount in investment that is indefinite, right? Sorry, in income. So when you have something like that, this is why you can't use Excel for that, because that's going to be a spreadsheet that never ends, or at some point it ends. But no, it does. Well, this never ends. In present value terms, you will be adding zeros at some point, but in fact, so you can't use Excel spreadsheet for that. And that's why I teach you to do it this way. All right, so for income, we have, I missed something?
Entiendo que tiene la venta de los 350,000 como si fuese un investment y los 200,000 del additional expense.
Well, I underlined that 350,000 is part of investment because this is the salvage value of the equipment. So that's not a revenue. It's seen as salvage. We put it together with the purchase of the equipment and investment. So that's the effect on investment, or the investment impact. You could argue it goes into income, but that's not how I'm doing it.
Y el additional expense de los 200,000 que está como esto.
And the additional expense will be in income under, it's red, con rojo. Additional expense. Where do you want to put it? So we have revenue and expenses both in income. And anything to do with the, anything to do with the investment, inventories are part of the networking capital that goes in investment, and it has a different tax treatment than an expenditure. We treat it differently, right? And I don't take the after-tax value of the networking capital, right? Because that's our operating expenses. We don't include it in the income portion. Are we okay? No? Julio? No, you don't like it?
Necesito.
You think that
Necesito los 200,000 porque eso es un income. That's it. The additional expense.
of 200,000, okay, let's see how I do it, and then you can complain. Let's see. Why is this doing this? Enter password. Okay, so I'm going to okay, so income, what I have for income, I'm going to make an annuity, right? And the annuity is going to have the 1 million of revenue minus the 200,000 of expenses. So the reason it says additional is to make you think it's incremental. That's the use of the word additional. So I'm going to take that off. And then I'm going to put that in an annuity for 4 years at 13.5% after tax. How slow is the video? Reload it to see the image, if it's slowing down. So that's what I have for income. Okay, what do you compute? Oh wait, do we put something else? That's just the income. I have that blue, no, that's red. And increase in sales. We should add it too, right? Even though we call it a side effect, we're going to add that as well. So add the 100,000 in a perpetuity after tax. Okay, give me a number.
2,153,780.
Sorry, say it again for the first.
For the first one, only the revenues and expenses,
Yeah.
1,413,039.
Yeah, very good. Is anybody else? Anybody else getting a different number? So what I would do using my calculator efficiently is I would store that in 1. And then the second portion, what do you get for the perpetuity? What do you get? I want to listen, but I have to turn the volume down. Okay, it looks good. So let's put that. What's the second part? Yeah, how much?
$444,000.
Sorry, it's 4. Okay, and then store that in 2. So you don't have to backtrack, okay? So just store them, and then. So I get 1,857,484.25, and I store it in 3. And that's it. So I done one part. In terms of rounding, when I say store, that's storing with all the decimal places, right? So you might be off in the decimals. I give some grace on the decimals, but when you store with all the decimals inside. Sometimes I don't know. I'm going to be flexible, but okay, so let's say once you're finished, so store 3, if you store it, it's going to hold all the decimal places. So I have technically all the decimal places there for income. That's, I think you should, yeah, I mean, it's actually harder to type it in and erase the decimal places. So it's easier just to store. Okay, just realize that if you don't store, you're going to have a little bit of a different answer. In debt, like in cents or tens of cents. It's not going to be much.
But it won't matter for the test, right?
I'm teaching you to do it with store, so I expect you to do it with storing and all the decimals. I think I've done that pretty much consistently. I'm just looking, like at this point, you know, having all the decimal places there, like I said, if you're going to write it out and retype it to remove the decimal places, it's just inefficient. So I'm just keeping it all decimal places. You're going to leave it to my generosity if you do type it all out again. You might get the wrong decimal places, or you might even have a keyboard error or a keying error by entering all these numbers again. There's a lot of digits here. 9 digits. All right, let's do investment. So income, the key there is you have to do everything after tax. In investment, it's a little bit different. I have the purchase that has a different tax treatment, the purchase of the asset, the equipment. So I'm going to put $1.8 million at the front, negative, on investment. And then I have to take care of the tax effect on the residual value of the equipment after 4 years. So first of all, we need to figure out what that is, right? So we need to make our Excel spreadsheet, or we do this by hand. Let's see if I can do it in Excel. I have some things here already. All right, so what we're going to put in here, so for the test, on your formula sheet, put the headings of this table that we make, right? Put the headings, because you need those, and you might forget. When you get nervous, you know, we forget things when we get nervous. So I sure what's happening. My keyboard is, oh, maybe it needs to be charged or something. That's probably what it is. Well, it says 100%. Sorry, I can't seem to get my keyboard. So you know what I'm going to do? So you guys can do it in Excel. I'll just show you what it should look like in writing, because I can't seem to open my Excel. So in Excel, you make headings for year or manually for the test. So it's year, then the depreciation rate, and we want the 7-year amounts. So at the test, for the test, I'll give you the maker's table. And then the third column is the D, the depreciation amount, the depreciated amount, and then the undepreciated cost of capital. So we're going to have 4 years. After the first year, we get to depreciate half of 28%. So 14.3%. And this is used to calculate the big D. So 1.8 million times 0.143 is what?
257,400.
Yes. Leaving undepreciated cost of capital of,
Sorry?
5,042.
yeah, so you guys are good. Are you guys using Excel or just did it by yourself? Okay, so then in the next year at 245.245, D is going to be 441,000 with undepreciated cost of capital of 1,101,600. Any questions about how to do this? And what do we find at the end? That the book value after 4 years so right, it's going to be $561,600. You compare to the salvage value. The salvage, you're told, is 350, right? Now the salvage value is the same as the market value. Yeah.
In the second year, why is it not 0.286?
Did I write the wrong number? Well, I'm going by the maker's table, right? If you did the table differently, you can use 0.286 and then subtract from the UCC. I'm not sure what you did. Are you using the maker's table?
No.
Oh, you're doing it a different way.
Yeah, I was just taking it and subtracting each.
Do you get the same answer in the end? 561, 600?
No, I didn't do it completely. I can do it completely.
Let me see. Oh, you did. Because,
I only did it first.
oh, you only did the first
And
row?
then when I was on the second one, I saw it was a different number.
Okay. Yeah, so in the maker's tables, you see, I'm using the 7-year, check on the video, the maker's table, or check in the on the maker's table in Moodle. So it's 245. So yes, it would be, if you didn't use a maker's table and you did 28.6, and there's a way to do this. There's another way to do this. I'm not sure if you're doing it that way, but you have to use the values in the maker's table to do it the way I'm showing you, okay? Because it's already taking care of the fact that the balance is declining. It's a very simple approach because they've made all the calculations for you in advance with the depreciation rate.
Making sure I can bring that to the test.
Which,
The maker's table.
oh, I'll give it, I'll put it on the test. Yeah. Yeah, I'll put it on the test because I'm using it to teach you. Yeah. Okay, so did anybody not finish the maker's table to get 561, 600? The salvage value was, you're told, is 350,000. And so what happens? What about it? So we did this calculation to determine the book value. The book value is 561. So it's worth, on the books, and what we've already accounted for in terms of depreciation brings it to $561,600. But the market value, and these are just estimates, but we're going to work with these to get numbers. So we'll just make it, let's say we found out in advance, or they found out that they could sell it for $350,000. So what's wrong, or what's going on? What do we do about that?
Now we can do the salvage value.
Sorry?
With that book value, we can look for the salvage value, right?
So then we compare the book value and the salvage value, and we see that we are selling at a loss. And so we can claim that in our taxes and reduce our taxable income. And this is actually another tax savings, tax shield. So what we're going to do is make a calculation, or add that to our calculation. So I'm going to add to $1.8 million the amount of the salvage value. So this is the formula I gave you, plus .4 times the difference, right? The difference, so this is the formula I gave you, the difference between 561, I think that's what I did. Let me make sure that that's what I did. So I showed you in the notes. Almost the last page of the notes. I told you take the salvage value and add the difference of the book and the salvage value after, times tax. In other words, if you sell it for more than it's worth, you have to pay taxes. If you sell it for less than it's worth, you save on taxes. So I'm going to take the sorry. Do that again. Salvage book minus salvage. Okay. I have the answer here. I'm just making sure it's consistent. Okay, so then the book value was 561. So basically the amount, the difference here, which is 211,600, times 0.4, and then you discount that because that happens in year 4. All right, so investment includes the capital expenditure, the effect on the, as a result of the sale of the asset in the 4th year, and net working capital, investment, cash flows. So what would that be? You're told that inventories will increase $300,000 worth and stay at $300,000 throughout the life of the project. So what is the impact of that? I have the table here, but I want to know what you guys came up with. For the networking capital investment cash flows, what does it add to the present value of investment or subtract? What are the cash flows?
Debt para 300,000.
Huh?
It subtracts 300,000.
You have 300,000? No. I mean, as a, right, so just 300,000? The inventory, yeah, it's about the 300,000, but what do I get from considering?
4,024, 423.
Okay, I'm gonna make the table like we did in class, all right? So networking capital requirements, 0, 1, 2, 3, and 4. So up front, you're told they have to increase inventory by a value of 300,000 and stays there, right, until the project ends. So it's 300,000 across. And then in the 4th year, 0. Okay, so you make your own table.
Do we have to make the table for the Excel?
Well, unless you know what to do. And I asked you, so what would you get? You don't have to do it if you know what you're doing. It's not just 300,000 because it's,
No, because on the solutions that you gave us on the model, it doesn't use the table if we, for the investment one.
which problem? Well, we'll look at it later. We'll look at it later. It depends how it's worded. It might be worded differently. In this one, I say increase immediately by 300,000 and will have to remain at the higher level until the project is complete. So I'm not sure what the other problem is, but we'll look at it after. Make sure we're consistent. So it's 300,000 across, and then the 4th year it's 0. So let's make the table for incremental. So networking capital, change in networking capital in the 1st year is 300,000. So the idea is that if we deplete our inventory before the end of the 1st year, then we have to replenish it. We have to keep it at 300,000 by the end of the year, each year. All right. So there's no incremental in that sense. Like we want to have $300,000 in inventory. So by end of year 1, there's no change, right? By the end of year 2, there's no change, 0, 0. End of year 3, no change. But then we release the $300,000 worth of inventory back to the firm. So that looks like a negative $300,000 in terms of the project. But then we use the final row of this table to compute the networking capital investment cash flows. And consider the perspective of the firm that the firm has to invest 300,000 and then 0, 0, 0, and then they get the money back. So this is not exactly a canceling operation of 300,000 initially and then 300,000 at the end of the 4 years is returned to the firm. Time value of money. So you need to take the present value of those amounts and put that into your computation. And what does that do? So that's going to be the 300,000 negative and then offset by 300,000 discounted this is, by the way, let me fix this. I just realized that has to be 1. discounted, 1.135 to the 4. Is that confusing? So it's going to be the 4-term, well, it's just the 3 parts, the investment, the salvage value, and then the net working capital, investment cash flows in present value terms. All right, so what do you get for all of that? The whole thing. Oh, you want to do it in pieces? In pieces.
I think should it be 1,605,738?
Yeah, very good. You guys are good. So she did that right, or we got the same answer. We made the same mistakes. I get a negative, right?
Yes.
Negative 1,657,318.75, and I store it in 4.
For the inventory one, I didn't use the table. Do I have to use it? Or can
No,
I
if you know what you're doing,
present value?
if you know what you're doing, it's fine. I'm doing this to show everybody where my numbers come from. You don't have to use the table if you know what you're doing, but so 300,000 up front, then no increases just in the last year. That 300,000 is released back to the firm. Okay, so the last piece is the tax shield, which is just an extension of the table. What I did was I just added 2 columns onto this table to make it easy in Excel. But we don't have Excel. Let's assume we're not using Excel. So to get these amounts, you just need the D column, the big D, for the depreciation amount, and you have to multiply that by the tax rate to get the tax shields in each year. So I can take just this piece with me down here. Multiply by the tax rate, where the corporate tax rate is 40%. Okay, so I get 102,960, 176, 400, 126, and 90,000. These are all tax savings, so they're all positive cash flows. And you need to put these into your calculator, sorry, to get the present value, but I will just write them. You have to write out the equation for the test, 257,400 after year 1. $176,400 after year 2. And what do you get? So you put them in with your CF keys. And what do you get? All right, so I get $368,054.02. And we're done. We just have to add these together, and just looking at them, can we see the answer? So let's see if I circle. This one's almost 2 million. This one is negative, a little bit less than 2 million. And then the other one's positive. So is it positive? That's all you need to know. You don't have to get the exact value in this problem. Sometimes I might ask you for the exact value. So as far as I can see, adding store 3, store 4, and store 5, NPV is positive. So invest. That was an easy one, no? Out of the ones that you've done so far, which ones were confusing? I mean, they were pretty straightforward. Anything challenging? Should I give you a challenging one?
If we were to do this in Excel, we'd probably do it by year, correct? And we'd sum a column by year.
Yeah. Yeah, if you did in Excel, just make another, so you have the column of D, and then the column of UCC, and then the column of TC times D, and then I would just take the present value of each and add them in the next column.
I mean, like, if we were to do the entire problem in Excel.
Oh, the whole problem? The only problem with this problem in Excel is, wait, we had an indefinite term, right? Not in this one.
Because I think if it.
Wait a second. Yeah, the only problem with this is the 100,000 increase in expenses in Excel. You can't put an infinite amount of cash flows in Excel. That's the problem. So you would have to add it or subtract it. Oh, we added it. It was revenues? I can't remember. Increase in sales, right. There was revenues. So you could do it all in Excel and then add that perpetuity. I mean, you could. I don't know. Some people really like Excel. I think it's, you should be able to do both. And if you can do both, this is easier, I think. I think it's easier. It's harder for me to mark if you make a mistake in Excel because you're screwed. Because you make one error and it ruins the whole thing. So think of it as presentation where you're less likely to, anyway, it's hard for me if you make a mistake in Excel to grade it. It's easier for me to see, oh, he missed, the exponent or something here. So for my sake, if you have something, anyway, you can't use Excel in the test anyways.
No, I meant the organization, because we did income separately and then investment separately. But if you follow the organization, maybe you can do it by year, then add the investments, the expenses.
But you mean year on rows?
And then get the net working capital year 1, and do it for year 2, year 3, year 4. And get the NPV of the years, and that's it. You only do one time value.
But you mean years in columns?
Yeah.
Years in columns for everything?
Yeah, and then you have the income, the expenses, and then the earnings before the taxes, and do it vertically by year, and then you just get one NPV at the end.
If you think that's easier.
And then I could do that by hand.
If you think that's easier. I think it's whatever, you don't make mistakes. If you don't make mistakes doing that, then do that. I'm less likely to make a mistake doing it this way because I can see, I haven't really altered any of the terms, the numbers. I haven't gone through and, like, you would have to do the after tax and then have all these new numbers. It's just so many numbers. In this case, the only place you can really mess up is if any of your components are added or compiled wrong. I just think Excel, doing it in Excel, just those numbers look so strange because there's so many new numbers that you don't know. If I'm supposed to grade it and you made a mistake somewhere, it'll impact all the other numbers.
Yeah.
Here I can see if you put in the expenses wrong, or if you forgot the deduction for taxes. But anyway, but thank you for the question or the comment. I'm doing it in columns.
In the next test, the second test, how much questions will they have? How many problems do you have?
Well, I'm going to give you, the whole class. So, like 4 problems on unit 3. I mean, something like 4 or 5 problems on unit 3 and just one big problem for unit 4. Something like that.
I have a question. It's gonna probably be no. Is there gonna be any bonus points for a bonus question, a very hard one?
You're asking for a hard bonus question? I don't know if you're gonna have time to do that though. Is that what you want? You're looking for bonus?
If I'm fast enough.
Yeah. I'll think about it. I just don't know if there's enough time. That's the only thing. I just want you to get the basics, but I appreciate what you're getting at. You want to help the other test, help your grades. Okay, so are we good for unit 4, or do you want a more bonusy type hard problem? You want to see a hard problem, or?
Yes.
Yes. I have a really hard one. Let me see where it is. So you didn't think any of the ones I gave you were particularly hard?
I also have a question. I also do the book exercises. Should I do them or is it a waste of time?
No, you can do them. Do they help you understand, or do they confuse you?
And they do, but they have different formulas.
They're doing things differently?
Yeah.
Yeah.
So should I concentrate different?
If there's a conflict between them, let me know. But
If I'm not mistaken, in the first test, I think it was the conversion of EAR, I had a different formula. But I still did it like that, and I got the answer in the test.
hold on a second. Just looking for a. Yeah, I'm gonna have to. I have some more challenging problems, but I'd have to pluck it out. And I'm not finding it easy enough here. Revised. Three. Okay. There's some more problems there. They're all very similar. Well, the layers of complexity can be where I say, haven't to have a growth in expenses by a constant amount, something like that, or where I ask you to compare two alternative systems, and you have to choose between them, and you assume all other elements of the case are the same in either variation of the systems. That's about it. But if you guys could handle that, you guys don't have any direct questions. What can I say? We can go on. I don't know. I don't feel like talking to you about the statistics unless you did the statistics review. No one did the statistics review? Nobody? Not good. Yeah, I feel like I have to stop here because I don't know. I mean, I really want to go on, but it's going to be tough. Let me Okay, so this is where we want to end up. So I showed you this at the beginning of class, but now what I've done here is I've put all the formulas that you're going to review for your statistics review into the format for finance. So finance is an application of statistics, right? Finance is an area of application of the statistical computations. And the first data set I give you here, is the same numbers as I showed you before, but all I've done is called them R, M, and RI. Are you guys watching? So R for return. And what do you see? What is the relationship between these two columns? Is there a relationship between these two columns? It's multiplied by 2. Okay. So if one is just the double of the other, what is the correlation between them?
Art.
What is the correlation between these two columns, these two variables? One is a variable, the returns on the S&P 500, which is an index that tracks the top performing firms through their stock and is a reflection of how the economy is doing. But these are just risky assets they're known as risky assets, being stocks. So in the other column is just a particular company, BCE, and its returns. So what is the correlation between these? What does correlation mean? What does correlation mean?
La relación no debería ser 1.
Excellent. Yeah, it's 1. It's exactly 2 every time. Exactly 2 double every time. That means it's a perfect relationship. It's a perfect relationship. So the correlation is 1. This is my brief statistics review. Okay, so the correlation is 1. So put these numbers in your calculator. You know how to put these in your calculator? Put these numbers in your calculator to get the equation of the line, the linear relationship between them. There's a linear relationship between these. That's perfect. So do you remember or do you know how to put these in your calculator? The TIVA 2 plus? No? So, okay, to put these in, that's what we can do. So go to your calculator and clear your screen. And if you hit second function, there are 2 statistical worksheets. One is data and the other one is stat. Okay? Data is a worksheet where you can enter the data. So there might be something there. I need to clear mine. So second clear work. So it's clear now. So it's kind of like entering into the CF keys in a way. So it's going to look like that. So I'm going to enter my data. I can enter it as percentage or I can enter it as decimals. What do you want to do?
Just to make sure it's cut off. It's X and Y. That's the 2 values, right?
Exactly.
Okay, so
So which one should be X and which one should be Y? Does anybody know?
the first one would be X and the second
Okay, but not.
S&P 500.
But what is the logic? What is the logic to making the first one X and the second one Y? I really don't like this board. Oh, I should write on my iPad. Okay, hold on. So it's an instinct to pick the first one as X and the second one as Y, but when we do this, in economics and finance, there should be a purpose. So which one should be X, which one should be Y? Even though when we look at data, just because there's a correlation doesn't mean that one impacts the other or one causes the other. Okay, we learned that in statistics, that just because there's a correlation doesn't mean that one relates or affects the other directly. But when we do economics and finance, looking historically at data, we do say that. And what here are we going to imply? We're going to imply that the market returns or the economy impacts the firm's returns. So the market will be the X, okay? And the Y will be the company, a firm I. All right, so that's the logic. I happen to put X as the market and Y as the firm, but just in case I don't, you have to remember that.
Is the firm part of the S&P 500?
Sorry?
Is the firm part of the S&P 500? Or is it just
Oh,
random?
yeah, the S&P 500 represents the market, and the 500, it might not be in there. It could be any other one, but the S&P 500 is kind of like a measure. This is where we're headed. I'm going to explain all of this later. Right now, all I'm doing is asking you to remember statistics because we're going to use it now in the context of finance. But I'm jumping ahead to the conclusion just because you guys didn't look at the review, but I'm going to try and tweak your interest, okay, before we go today. All right, so let me put it here that this is going to be our X always, will be the S&P 500, and the Y will always be the firm. All right, so back to our calculator. So let's put this data in our calculator. You kind of know how to do it, right? So you're going to say, do you want to put in 0.15 or 15? 15, let's put 15. 15, enter, and then arrow down. Now it asks you for Y. Now you're going to put 30, enter, down. Now it's going to ask for the next pair. The next pair, 9, enter, down. 18, enter, down. The third pair, 10, enter, down. And 20, enter, down. The fourth pair, 7.5, enter, down. And 50. Is everybody okay? And then 8, enter, down. And 16, enter, down. And then, so make sure you have everything entered properly. 15, 30, 9, 18, 10, 20, 7.5, 15, 8. Oh, I made a mistake. 16, enter, down. Good. So check your values. All right, so now what do I do? Oh, wait, did you get it in there? You got it in there? Make sure you have it. Use the arrows. So this will not go away unless you clear the worksheet while you're inside, right? It'll stay there.
Once I put all the values, what's the next step?
Okay, the next step, is everybody there? You put all the values. Now, second stat. Second stat. And what does it say on the screen? Second stat. What does it say? Lin. What does lin mean? Linear. 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 Okay, because you're going to get the linear estimates, the linear relationship between the two. So let's look at that for a second. Let's go back to our chart.
Data?
This drawing that I made, right? So this drawing that I made, check the screen, the video on YouTube. So the data will look like a perfect line, right? It's going to be a perfect line. Do you guys watch it?
I'm still in the calculator.
Oh, it's just behind. Just wait. It's going to show, or reload. Okay. So it's going to be a perfect line going up. And what do we know about that line? Let me put this a little bit more here. So these are the values, right? There were 5, so I got to do one more. So let's see in our calculator what that line looks like. So to go through Lynn, use the arrows to go down, and it tells you 5 observations, arrow down. It tells you the mean of X, the standard deviation of Y, and this, what is the third one? What is that?
The population.
Yeah, you're close. But what do you mean, the population? It means,
Population.
okay, so the results are this. X bar is the sample mean. SX is the sample standard deviation. And if this was all the data there was, if this was the population of data, you should use the second value, sigma x. But because this is only a sample, you use SX as the sample standard deviation. I will review all these things. You have to watch the videos, 4 hours or 5 hours, whatever I have there. Okay? Now keep going, scrolling. Now it shows you Y. Y, the mean, the standard deviation, and those are the samples mean, the sample standard deviation, and then the population standard deviation. What is the relationship between the sample standard deviation and the population standard deviation? What's the difference in the calculation? What? Look at the numbers.
No,
Huh?
it doubles again.
Not doubles, but no, I mean, what is, yeah, but not that. No, I mean, between S, X, and sigma. So I mean, what's the relationship between SX,
And that's why.
oops, SX, oh my gosh, this is driving me crazy. SX and sigma X, what's the relationship between those two? Which one is bigger?
The sample.
Why?
Because the sample's only this part, the other one is it's big, it's its population.
That's not the reason, but that's good guess. It's a good rationale, I guess, but that's not the reason. It's because when you calculate the sample standard deviation, so basically they're both calculations are using the same set of numbers. The difference is the formula. The formula for S divides by n minus 1. The formula for sigma divides by n. So because you're dividing by a smaller number, S will be bigger. S will always be bigger.
So if it was closer to 25, it would be closer to the mean of the population, right?
Say it again?
If it was closer to 25, it would be closer to the mean of the population.
Oh, that's another issue. That's something else. But the point is that when you have a sample, the formula is different than if you have the whole population. And very rarely do you have all the population of data, but we teach you about what we're trying to get, okay? S is an estimate of sigma. So sigma has a formula, but because we don't have all the data, we don't use that formula, but we have a formula that looks similar, the S formula, which divides by n minus 1. And I explain that in the videos. Just watch it, okay? All right, so what do we get? Keep going. So keep scrolling. Scrolls SY, and then you get A. What is A?
Alpha.
Okay, it's alpha. It can be alpha, but what does it represent?
It's a significant value, isn't it? Significant.
It's a he's so courageous. He's going forward. You guys help him. A.
It's the thing like this, isn't it? Like,
Oh, you're talking alpha. Oh, you're talking about level of significance. That's not what A is, but it's okay. I appreciate you're remembering statistics. Okay, there's A, and then there's B. What is B?
that linear formula.
Exactly. That's the goal. This is the linear. This lin. Okay, and then what's next?
Regression.
Correlation.
Correlation. Julio told us, right? It's 1. Okay, so what I'm trying to establish here is that the power of your calculator will get all these values for you, but you need to know what you have here, okay? You need to know what you're doing. So it's the 1 refers to the fact that R equals 1 means that that those variables are perfectly positively correlated, perfect, all on a line. They're tight on a line. The A is what now? If you think about a line, what does the A part mean? The y-intercept, very good. So the y-intercept in our problem is 0, right? Because it goes through the origin. It'll just go right through there. If I put a line through these dots, it will go right through the origin. Right.
I have a question, Professor.
Wait, let me finish.
Yeah.
And B, what is B?
Slow.
And in our calculator, what is B? So finally, with everything that I've said, the 2 that he identified as being the doubling is reflected in the slope. Okay? The 2 that you see that it's double will be the slope of that line. So everything that you see, I'm relating it back to statistics that you've learned before, that it makes sense. Okay, now you can ask me your question.
And does this have to do with, you know, when you see in Robin, for example, it has a beta?
That's what we're going. That's what you're going to learn. That's what we're going to learn about beta. Very good. But what I've done here, okay, let's just go back a bit. So this is, so what we've done is I just asked you to show the relationship between these variables, all right? You just looking at them, you see it's a perfect doubling of the data. And we calculate, with our calculator, we can get the average of X and Y. We can get the standard deviation of X and Y. We could even get the correlation of X and Y. How can we do that with our calculator? Okay, I want you to go back to your calculators. Let's see where we can get that other information. If I keep scrolling, what do I get? Oh, look, there's some more stuff here. Oh, there's more. So if you keep scrolling, there's more information. As you scroll, keep scrolling.
R is R.
Okay, after R, keep scrolling. Keep using the arrows down. What do you see?
The sum of.
You see different components, right? You see different components. Now, which one will help us to get other data, other variables, or sorry, other statistics? So keep scrolling to the end. The last one is X times Y. So you see there's all these other statistics here. So far, I have the equation of the line and I have the regression coefficient, and I'm just putting it in your mind that there's other data in there. There's other, statistics in there. There's other components of statistics in there for you. So what I'm going to talk about now, and I'm just showing you pieces of this because you have to go consistently. You have to go systematically through everything I gave you. But okay, let's go back here. The data that I gave you is known as ex post or historical data. I said period 1, and I gave you the pair of data. I gave you the value of returns for the S&P 500 and the value of returns in that period for BCE. And then the next period, I give you the pair of returns for period 2 and the pair of returns for either. And I treat every single observation as equally likely. I don't favor any set of any pair. I say they're all the same value to of information. And I just calculate statistics. I calculate the statistics, treating it like that, okay? However, I can have data. So this is like after the fact, historical data. All I did was look at past prices. All I did was look at, and you're going to see when we talk about it, how I calculate these is essentially just looking at past prices and dividends received to get these numbers. Okay, that's all we do to compute those. what if the data appears in a different way? Let me get the,
Expected return?
yeah, like if I use other information to create what's called ex ante returns. Let me see. Ex ante. I think it's this one. Okay, yeah, here. So I repeatedly use this data to make my point. What if data appears like this?
It's loading slowly.
It's loading.
Yeah. You multiply 0.4 times 0.14, and that will be your expected return for market X, and then 0.4 times BTEY.
Okay, so you remember you have to use those, so there's an extra column now, probability. So in other words, this data, this set of information favors which state? Which one is more likely? Normal. The normal state is more likely than the other ones. So every data point here is not equal. So we need to use what's called the weighted mean, the weighted standard deviation, the weighted correlation. It's just a different set of statistics to incorporate this more general case that not every observation is the same. So this is what I need you guys to review, because you might have learned it and you forgot it. So you really need to review that. It's very important. Now these numbers were used, so this set of data was not just based on past prices. It used past prices, it used projections of future economic circumstances, it used information on financial reports of these companies. Okay, so all of this was put together to come up with 3 states of the world: a boom economy, a normal or status quo state of the economy, or a poor recessionary economy. Now this is actually, as maybe complex as it looks, this is actually very simple. This is called a discrete distribution. Okay, it's showing you only 3 possibilities. What's the truth? There's infinite possibilities, right? We know there's infinite possibilities. I'm only giving you 3. So figure out how to work with the 3. Because in fact, this is a simplification. If we were to incorporate calculus, we can do this with a distribution that is a continuous distribution, but we're not going to do that in this class. But in reality, that's what you should be able to do, okay? So this is very simple, and there's formula here that I apply. So you need to practice calculating. See, I have the average, but I use different symbols. Notice, I want to get my formula sheet. Just a second. Give me a second here. Let me get my formula sheet. I know I have a formula sheet here. Anyway, I know I've put it on the platform. Let me get the platform. Let me do it here. So what I have here in the platform in Unit 5, I have all those sheets. Okay, so we have the statistics review documents, solutions, scatter plots, and then the formula that I've been discussing. And then I have the 2 sheets with the solutions to solving those. So let me look here. Okay, actually, I'm gonna look at this set of formulas. So this is the statistics that you learned. The statistics that you learned. This is the. I use the. Actually, I have to fix that because that's not the one. Okay. I'm gonna fix that and put in the, because what I have is this one. No, you're missing a document, so that's all right. I'll put that up. These should be different. The one that says risk and return formula should be different from the finance notation one. Anyway, let's work with this. So here is the ex-ante data. So wait, let me scroll here. Okay, so looking here at the historic or ex post returns, where every data point is equally significant, right? And I can calculate the average return, the standard deviation of returns, and I use R for the variable. Now I can do that for the returns to the market. I can do that for the returns to the firm, the same formula. So you have the average, the standard deviation, and I use the symbols R bar and sigma hat because it's an estimate of the population standard deviation. And then I have covariance of returns. So you should be able to calculate all of those.
Just making sure, Professor, question. The first one is E is expected and R is its return.
So the R bar, E expected return, that
Yeah, R bar, and then the E stands for expected, and then the R would be the
return. Yeah. Yeah, so it's just the average. You see, it's just add them up and divide by how many there are, T for time. And then the standard deviation is a sigma hat, so it's the square root of the variance. Then there's this covariance that is a very long looking thing, but it's basically, it's the variance. It looks like the variance, but it's not. It's the covariance. But there's a relationship between the covariance and the correlation in the third row. What is the relationship between the covariance and the correlation in the third row?
The third row, we can't see it really well. Can you go a bit?
You can't see it? Oh.
Oh, sorry, that was me. I can see it now.
So what's the relationship there? How can you describe the relationship looking at those formula?
It uses the one above.
Right. The correlation, I use the symbol rho. It's like the Greek letter R. And it's a Greek letter R, it looks like a P, but that's correlation. The correlation is like the covariance. What's the difference?
Multiplica entre uno sobre el covariance.
So the correlation is like the standardized covariance. You take the covariance and you reduce the covariance to a range of values, -1 to +1. You remember that? And the way that's done is you divide by the standard deviation of each variable. That's what's happening here. So I really want to find that other, so because this might look weird to you, you didn't see this yet. I actually had the data, I have the values, I have the formulas just as you learn them. I want to open it before we go. I can't find it. Okay, this is better. So this should look more familiar to you. I'll wait a second for it to load. You see it?
It's still open. Now, okay, where do we want to? Where it says compute the regular mean?
Yeah, so then you have the mean, which is the arithmetic average, the standard deviation. These should all look familiar. Covariance, everything should look familiar, right? And then R is the correlation, which is covariance divided by the two standard deviations. When you do that, you reduce the value to a range of -1 to 1, so it's easily interpreted. The covariance alone doesn't make sense from sets of variables to other sets of variables, because it can be, the only thing that we like about covariance and correlation is that they have the same sign. If covariance is negative, correlation will be negative. If covariance is positive, correlation will be positive. But what we like about R being between -1 and 1, it tells us about the trend of the data, right? So that's why, so if you have, so this is where I'm going back to your calculator. If you have R in your calculator, and you have SX in your calculator, and you have SY in your calculator, can you find covariance?
Yeah.
So that's the main point I wanted to make, okay? That you can get all these statistics here using your calculator, just like I showed you.
But question, is it okay if I just insert what I got in the calculator there in formula?
If I am asking you, if I ask you for covariance, you should be able to use R, SX, XY.
Directly from the calculator?
Well, you probably have to write the numbers down or something, because, well, it would be easy here, like, because you know, when you're going through your calculator, it's SX, and then you have to write down, and then SY.
So, yeah.
You can't, like, extract them, unless, well, maybe you can save them, store 1, store 2.
But for the case of this formula, for example, I can just go down, R would be 1, then and I just put them, and that's it?
Let's see. So if I have the data here, and I say SX, and I use store 1, and then SY, store 2, and I know R is 1, right? Then that should be the covariance, 18.1. If you make this one. So basically, you can get all these statistics from your calculator. Are you good with that? I mean, in our problem, R was 1, so I didn't bother storing it.
So just to make sure I'm getting it, R multiplied by XX and XX multiplied by XY would be just a equivalent. So I think it's used as a formula. So,
It's a trick. It's just a trick to get it out of your calculator. But the black box, in the black box are these formula, okay? Like, I'm showing you how to use a calculator, but you need to understand this, the application of these formulas. You should be able to produce these formulas in Excel to get these numbers as well. You should be able to apply these formula in a table and get the same number as well, okay? It's just that this is more efficient. At your level, you should be able to do this efficiently. So what else on these formulas? So I've shown you covariance, which you can get by R, SX, SY, you can get covariance. And then that whole, this entire column here of covariance is just different ways, formulas for the same correlation formula. And then finally, I end up with B. B is what?
R multiplied by the division of X. Y.
Yeah. And I make a point, if you want to remember this, like I'm allowing you to take a formula sheet into the exam. Obviously, you want to copy this stuff on a formula sheet. But to remember this, for people who don't have the advantage of a formula sheet, remember it as let me make it bigger. it spells risk. Okay, so basically R times first SY, then divided by SX. Risk. It's a mnemonic.
But
It's-
I didn't understand the mnemonic. Well, how was it? R multiplied?
It's R multiplied, okay, you know, to calculate B, you know it's the standard deviations divided by each other. Okay, you need to at least remember that. But which one comes first? The Y and then the X. Okay, so B is the slope. In our example, it was 2. And it shows the sensitivity of the firm's returns to the market. It amplifies the effect by 2. So if the market performs at, has a return of 15% in a period, BCE has returns of 30%. That's awesome, right? But what if it's negative 15%? That's not good, because then it's going to be negative 30% for the firm. That's the idea of risk. That's the riskiness. This is all going to make more sense when we go through the unit, but this is what we're going to talk about in the unit, okay? So the slope that you've learned for other variables and other statistics courses that you've ever taken, if none of you have taken statistics, now you're learning. This is a summary of the most important things you need for finance, okay? For this course anyway. So how many of you never took statistics before? You all took statistics with me? No, some of you? So I discussed this, no? I discussed this, yeah. It's the same notes. So, all right. So what I have on the screen right now is the notation you learned in your statistics course, if you took statistics. X, Y, S, R, covariance, and all these symbols, right? Scroll down, now let's look at the ex-ante data. Ex-ante is before the fact. This is predictive. And I'm assuming that when I do this, that this is a distribution of what's to come. There's only 3 possibilities. Boom, normal, and recession. Not infinite. I've reduced it to 3. Because it's all that can exist, now my statistics are population statistics. Now I'm going to use the symbol mu for mean, sigma for standard deviation. They're not estimates anymore. Okay? So that's what you see here. And the calculations are made as weighted statistics. The weighted mean, the weighted standard deviation, the weighted covariance, the weighted correlation, and the weighted beta. So that's where the beta comes from. The beta is the slope of the relationship between market returns and a firm's returns. That's the beta, or slope, okay? Different, the beta, the slope, the 2 in the exercise that we did before is different than the correlation. What was the correlation again? 1. What does correlation mean?
If the S&P moves 15%, the other one will move double, so it will be 30%.
But always double, no matter what. That the relationship is perfectly,
Which is good if they have a bull market. If they have a bear market, it's over.
It's that it's perfectly on a line. Let me go back to my drawing. Where did I put it? My drawing is here. Perfectly on a line. So correlation, you want it to be high, but the reality is correlation between 2 variables is often not so high. The meaningfulness of the slope depends on the correlation. So let's say you had, I better do it here. so let's say you have an R of 0.2 and a B of 2. R of point, I'm just keep using the slope of 2. So let's make this higher. An R closer to 1 makes that relationship more likely, right? Because it's saying that it's more consistently 2. So if I have data, so let me draw what an R, let me do that again here. So data can look like that, all scattered around. And the least squares regression line that goes through the data might still have the same slope as it had between these and these two. The slope is the same. It's the same slant. However, you feel more secure when R is 1 that the slope is actually double. Okay? And how are you going to know that you should be more secure? You look at the R. They are related. Look, R is in here, but they're different numbers. Okay? So slope is different than R, but R goes into slope. The main thing to realize here between the R, this will always be positive. SY will be positive. And SX will be positive. Why? Why will they always be positive? Because what is the standard deviation? It's the square root of a variance. The square root of a number will always be positive, right? So those will always be positive. So whatever sign R is, B will be the same sign. If this is negative, this is negative. If R is positive, B is positive, okay? So just to draw my last drawing here, so in reality, things don't sit straight on the line. There will be some variation. There could be a lot of variation. Again, I've drawn this with the same slope, but more tight. So the R I make there as 0.75. I'm just trying to differentiate between correlation and slope. They are related, but they're different numbers and they mean different things. The one thing that's the same is the sign. If R is positive, slope is positive. If R is negative, slope is negative. Okay. So there's my statistics review. You guys have to practice. Do the whole review. And I'm going to stop here. Do the whole review, and this will all make perfect sense. Okay? And then when we get back after the test, while you guys are going to work on the... what I'll do is I'll post... For my first set of notes, I'll post a video so you guys can get ahead on the video without wasting time. And then when I see you in 2 weeks, we can finish unit 4. 5. By May 2nd, we're going to finish unit 5, or almost finish. Okay, we're going to feel good about it. So I want you to, you guys are good for the exam. I could have given you the exam today, I think. But so spend the next 2 weeks working on Unit 5, doing some problems. I don't know, you need more problems for this test to study?
Yeah. I'll take them.
I'm going to give you all my problems. I have nothing for the exam. That's the problem.
That'll be good.
Well, I do want you to get to studying this though. So do the reviews, and I'll put up something for the first set of notes. I'm going to open up all of Unit 5 because there's a lot of material there, so you can see it. So are we good?
Nervous.
For next week, you guys did so good on that exercise. I was so impressed. Most of you seem very confident. Prepare your formula sheets. The one we did at the beginning of class. You mostly looked like you knew what was
I'm
going.
ready now. See the exam.
Oh.
It's another thing.
Oh. Well, just ask me lots of questions. Just ask me lots of questions. Yeah, you also have to study for the review. So that means that test.
Okay.